ahead of our schedule. So Ramon and I are here, but we will start the webinar at 4:01. But in the meantime, we can do a quick sound check. So if you hear us, please type in something into the chat so that we know that all is good.
Test, test, test.
Oh, thank you, Kevin. That's great. Thanks, Mark. Excellent. Good. We still wait.
Maybe you guys can tell us if you see this first slide. Nice.
Very good. Good. We just give it a few more seconds until we start. Recording has started. Yes, so we are all good. To the recording, the session is recorded, but in the end result, nothing will be visible. So don't worry, nobody will see that you have attended the webinar. So just Ramon and I will be visible in the end result. Good. It's 4:01. There are a few people more joining. Let's give them a few seconds to settle in. Good. So thanks everyone for joining us for our COVID and AWS webinar. So I have here with me Ramon from AWS, which will lead through the whole session. Hello, Ramon. Hello, everyone.
Everybody.
Thanks everyone for taking the 45-50 minutes that we will run through the session this afternoon. So this one is the second in our AWS skills series that we have set up with AWS. And today we will look at serverless technologies, which Ramon will present. Ramon, next slide, please. So the webinar 2, which is happening today, is actually on my birthday. So that was not a good idea to set up a webinar on my birthday, but that's how it is. We are still doing it, and Ramon and I will lead through this webinar. Next slide, please. So for those of you that don't know Copit, Copit is a born in the cloud company. We have been around for roughly 5 years. We are fully focusing on AWS technologies, on container technologies, on Puppet and for automation, and that's all what we do. So we have been around for roughly 5 years, or 15 people, and we do obviously also cloud consulting to build foundations and help clients transition into cloud environments on-premise and off-premise. Of course, we love most AWS as our main public cloud provider, or actually as the only cloud provider. So we mainly work with AWS as Copit because these guys have built such a phenomenal offering that we don't have to work with any others. So AWS is our choice, and that's why we are here with AWS to present to you serverless technologies, which are super exciting, and we have done quite a few projects over the last 3 years in the serverless world, and Ramon will show you in the next couple 40-45 minutes what's going on in the serverless world. And Ramon, I think I give over to you so that you can lead it from there.
Sure. Thank you, Marco, and also happy birthday from my side. I didn't know it's your birthday before coming into the meeting.
Thank you.
Cool. My name is Ramon Lopez. I am a solutions architect with AWS. And today it's really my pleasure to talk about serverless technologies and give you an introduction into what is serverless. And we will talk about a few different topics. And I really want to focus on the demo part, which is in the second half of my presentation, to show you hands-on in the AWS console what serverless technologies can do for you and what you can build with serverless technologies. We may have some ideas of what is serverless, and people have individual ideas of what exactly it is. I think it's a way broader topic than most people believe. And this presentation is really trying to give you a high-level overview of what is there in the serverless portfolio of AWS. So we'll talk about the definition of serverless very quickly, and we will talk about where and how do our customers use serverless technologies, maybe to give you a bit of an inspiration and motivation on, in places where you haven't used serverless at all. And then we will see a bit of a comparison between different serverless technologies. We'll talk about Lambdas and Fargate, and also storage technologies, which are serverless. And usually people don't think about them when they think about serverless. And then we'll jump into the demo, which is an event-driven system, an event-driven architecture that I've built and put together for this purpose. And at the end, we'll have a few minutes also for questions. So if you have any questions, take a note, please, and bring them to the end of the presentation. So what is serverless, right? It's definitely a buzzword, but it's something very concrete. And it really means that AWS takes away all of the maintenance effort that you would have with running traditional servers. So traditionally, let's say a web server that hosts a website or that hosts a service, you would need to do operating system maintenance. You would even need to, first of all, choose an operating system and install it, maybe build an image, package it. That is not there anymore if you use serverless technologies. You really bring code, or what you can also do is you can bring containers, and you kind of hand them over to AWS, and you can upload them in the console or through an API, and AWS runs this code or those containers for you, and we do it in a highly secure and highly available manner. That also means that we make sure that those workloads, your code, your functionality, your business logic stays secure and is updated. So we do, all of the maintenance, all of the patching and updating of the underlying operating systems and frameworks. We take care of the availability, as I mentioned, and you can use a lot of the functionalities which are, so to say, extra when you use serverless technologies, like snapshots. We take regular snapshots. We do replication of your workloads across isolated availability zones. So even in catastrophic failure scenarios where you have flooding maybe of a single data center, your workload stays available because it is replicated across multiple areas, geographical areas by AWS. And this is all transparent to you, so you don't have to actually do any of that on your own. At the same time, you stay in full control of the permissions and the security and the configuration of who and what can access your workloads. So if, let's say, example, a Lambda function that we will see a few of them later, you control who can call this Lambda function under what circumstances, and you have precise configuration measures. Also, when it comes to deploying code in a serverless manner, you can still do things like AB or ABE, whatever deployments, in blue-green deployments. You can do versioning however you want to. So we're not, in a sense, opinionated in how you can deploy, integrate, test your systems. And so what is a motivation to go serverless? I probably mentioned a few points already. You can, first of all, get to market faster because you don't have to choose, provision, maybe order a server, an operating system, and so on. And also you don't have to take care of the networking connectivity between maybe multiple machines. You can get to market really quickly. You have code, and usually this is where your business value lies in. You know what you want to build, and you bring it to a Lambda function, you bring it to an ECS Fargate environment in a container maybe, and you just run it. And this is really a matter of minutes instead of weeks and months. Overall, you get a lower total cost of ownership because these serverless components, they scale, but they don't only scale up, they're really elastic. So if there is a need for a high scaling application, let's say again a Lambda function, it will scale with the traffic that you have on the Lambda function. If, let's say, at night or during low traffic hours, it will not incur any cost, or it will incur very little cost only. So there is no over provisioning anymore with serverless technologies. I mentioned the scalability and the high performance. So both of those in many cases go hand in hand. Because they scale automatically, they are performant when you need them, and they are available at all times when, essentially without you doing any of this really difficult work. So what customers build with serverless technologies is a lot. Essentially, every use case you can imagine can be built on top of serverless technologies. In the past, many of the use cases were in the data processing realm. So you have let's say, a non-time critical work to do. You would maybe use a Lambda function for that. Let's say, minify a image. You want to create thumbnails. This is one of those typical use cases that people were using Lambdas for in the past, and this is still a great use case to do it, to use Lambdas, but it's more than just that. It's really about integrating workloads with serverless technologies that are very difficult to host and maintain on your own. So there we're talking about IT automation use cases. Because you're, for example, you have the ability to bring containers. You can take those containers that are currently maybe in a very complex container orchestration environment, and you just bring it to ECS Fargate, and we take care of hosting that container, connecting it with your other components of the architecture. Web applications are, of course, a big part, and let's also not forget about the storage aspects, and I'll talk about that in a minute. Web applications, they need different flavors of storage, right? You need caching technologies in some areas, you need relational databases in some areas, you need non-relational databases in other areas, and all of that is covered with serverless technologies. And also machine learning is becoming a bigger part, where serverless is interesting. If you think about classic machine learning use cases where you have infrequent training needs, you can essentially, you build something in let's say a Jupyter notebook, and then you want to train a model for a short amount of time, and then maybe you want to host different versions of the model on different endpoints. This is all where serverless is really interesting, because you don't want to be paying 24/7 for a full year for, let's say, a huge machine where you only use it a few hours a day at max to train your models. When we talk about serverless architectures, it's a different mindset, a different way of thinking. We all know these monolith versus microservice comparisons, and this is absolutely the way to go also with serverless. What we really want to foster is a thinking of small pieces with a very specific use case in mind, and those small pieces being very, I would say, specialized for each use case. So you have many different tools in the serverless world, and you choose exactly what you need for that use case. And the demo will hopefully illustrate that way of thinking. It's a simple architecture in a sense, but it contains multiple small pieces, and very deliberately we choose which service we use in which occasion. And the example here that you have on the right hand side is a good example where you have topics. So you have, so to say, a publish subscribe model. You have in the middle Lambda functions, which do some sort of processing. And this can be code from Java to JavaScript to Python and many others. And then we have different storage needs. So you have a serverless database, for example, a DynamoDB table, and you have blob storage in S3, and both of them are serverless. So you pick and choose those small pieces, and in the past you wouldn't do that because every single piece is additional complexity, additional knowledge you would need. You would need staff and employees to understand all of those technologies, and that takes a lot of time and resources. With these serverless technologies here, it's different. They are, in a sense, in how the way you approach them is very similar, and they're easy to learn. They're easy to understand and use, and it gives you a very predictable behavior because you know, okay, I have this need. For that, I will choose maybe an SQS queue, and you know what you get from that queue technology, and we take care of replicating the queues across availability zones and really the reliability aspects that you need from, let's say, a queuing system. And so a really nice way of thinking is in the compute world, so not talking about storage, just in the compute world, what you want to manage. And there we have at least 4 levels, I would say. So you look at the lowest level, which is a standard EC2 machine, where your level of involvement, so the level of what you actually have to manage, is quite high, right? So we take care of the physical hardware, of course. AWS provides the physical layer, but you take care of the exact network configuration. You take care of scaling the machines up and down. So you would provision multiple machines in different availability zones. You configure the network aspects of it, which ports you want to open, these kind of things. One level above that, you would have something like Amazon ECS and EKS, which are our container orchestration services. ECS is the Elastic Container Service, which is a container orchestration offering that is built by AWS. And EKS is the Kubernetes, so to say, the native Kubernetes offering from AWS, where you can host your own fully fledged, fully compatible Kubernetes environment in the cloud. There, we, so to say, control the control plane. So we make sure the control plane of both ECS and EKS is highly reliable and durable. And you just bring your worker nodes, in a sense. But the underlying infrastructure, the underlying machines that make up all of your worker nodes, they're still managed by you. Then one level above, we have AWS Fargate. And this is where things become really interesting in terms of serverless. You still have your ECS or EKS cluster. So you get the same type of interface you would have with EKS and ECS. But the underlying compute power, so the underlying machines, if you will, they are abstracted away from the customer. So you just define which containers you want to host. You bring your containers, your business logic, your application code, and we manage all of the underlying infrastructure. And the topmost offering here, AWS Lambda, is where, and probably many of you know it already, is really you just bring the code, literally just your 50, 100, 1,000, whatever lines of code, and you either put them into a repository and deploy from this repository into your AWS environment, or you literally copy paste code into the AWS console, and you say, okay, this is my my Python Lambda function. You maybe define a timeout. You maybe define if you want how much RAM, how much memory that function should use at a maximum, and you click deploy, and we run it and deploy it, and you can already call it. So this is the most extreme form of serverless, where we take care of everything except the application code. And I mentioned before that serverless is more than just compute. So we have, of course, our compute offerings, which I've shown you on the previous slide. And actually, there is even a newer one, which we will see today, which is not on this slide. It's called App Runner. But there is more. There's more than that. There is different storage options in the serverless world. So we have S3, which also, if you think about it, you bring your object to use an API, and you can store any objects from tiny to huge in the AWS cloud, and automatically it's highly durable, replicated across multiple availability zones. And I should also mention, it stays in one region. So if you bring it to, let's say, the Frankfurt region or the upcoming Zurich region, it will stay in that region, except you explicitly say, let's do cross-region replication. You can do that as well. But AWS takes care of the security aspects, the reliability aspects, and you just use the API to save and to version and maybe to delete and to retrieve those objects. Then, for example, we have Aurora Serverless, which is a MySQL compatible database offering where you use a standard MySQL interface, but the underlying infrastructure is completely managed by AWS. And then on the right-hand side, we have DynamoDB, which is a NoSQL offering, where all you have to do in terms of scaling, for example, is you could say, you could define maximum scaling numbers. So to which degree you want your tables to scale up. But there is no server, no operating system, nothing that you would touch. It's, again, just APIs that you use. And the bottom layer here, there's a few other technologies which are also serverless. You will see two of them in the demo today. In the middle, you see SQS and SNS. So SQS being the queuing system, the simple queuing service where you have maybe an event-driven system like in the demo today, where you want to bring work items to a queuing system, and then you have consumers which, as you know, the consumers scale up or down, they just take work out of this queue. And this helps to distribute and also to decouple components in your architecture. Makes them all in all more reliable. And then SNS, we will also see it in the demo today, is a publish-subscribe system where you just define in the AWS console, I need an SNS topic, and you can publish messages of essentially arbitrary format into this topic, and then you can have one or many subscribers on the other end of such a topic that can receive those messages, and they can do whatever they want with those messages. You get a lot of functionality on top of that, of course, which again is taken care of by AWS, like the reliability aspects, but also this fine-grained control if you need it. So you could say, I want my messages in the queue or the topic to be available for a certain amount of time. You can clearly and precisely define how you want to deal with error cases as well. So if you want to say, I will allow 5 retries, after 5 retries, I may want to move my message into a so-called dead letter queue. You can do that. You can say, if after 5 retries, a certain message wasn't processed, it moves into a dead letter queue that allows you to debug and maybe reprocess at a later stage. So we're moving into the topic of event-driven systems, and I mentioned this topic because it's relevant for the demo, and essentially event-driven systems are becoming the new norm in a sense, especially in the web application world, where we're dealing with a lot of smaller services. You may want to call them microservices, but whatever the case, the goal is really to decouple as much as possible while still having a high quality of service, a service which is very, very, I would say, fast, So queuing in that sense doesn't mean that things become slower. It just means that they become more independent from each other. So a few of those terminologies, a few of those concepts that we use in event-driven architectures are the following. On the left-hand side, you see something that is called an event router. So events can be anything that is interesting, maybe there's somebody or a team or a service is interested in an event in your domain, in your business. That event router will then accept this incoming event. It could be an order in an e-commerce system, and will distribute it to the other parties, to the other components that need to know about this event. So an order comes in, maybe the event router would route it to, for example, a fulfillment service, and also to something like an accounting or invoicing service. So this is the way you can imagine an event router. AWS has something called EventBridge, which is heavily used in that area. We will see an architecture on the next slide. But this is the idea of an event router. The second concept here is the concept of having asynchronous data processing and asynchronous events. So instead of having two services that communicate with each other in a synchronous way, where service A calls service B and says, process this item and give me the answer, and then service A would wait until service B really comes back with the answer. You could have, for example, a queuing system in between, but essentially you're decoupling this flow. You're saying service A has something that it wants to be processed. It submits it to a queue or some other system that serves a decoupling purpose. And then service A can go and keep working on other things. And once service B is ready with this processing, service A will pick it up. But there will be no more waiting and blocking until service B does something. Why we do this is very simple. Service B could have all sorts of issues. Maybe it's not scaled. Maybe it has a faulty deployment. Whatever the case may be, you want to really encourage graceful degradation. So even if service B is having issues, you want service A, which is maybe the thing that your customers are in contact with directly, to function as normal as possible. And for that to work, you need decoupled systems. So even if service B has an important functionality and is an important part of your business, service A can continue working maybe in a degraded way, but you don't just throw your hands up at service A and say, sorry, I can't do anything anymore. Here is an error message or an error page. And the third one here is event stores. Event stores are something like queues where you could have events coming in on one side and processors, consumers on the other side, and they take items out of these stores as fast as they can. But that's the point, as fast as they can, not faster. So if you have the ability, you can scale the consumers. If you don't have the ability to scale those consumers, they just keep working. The queue fills up a little bit, but they will not be overwhelmed, for example, with messages. So it's essentially a buffering mechanism. And this is just one example of a customer, the Lego. We all know Lego. They use a heavily event-driven architecture when it comes to their e-commerce site. And of course, e-commerce applications, they have traditionally challenges when it comes to very spiky traffic on Black Friday, for example. And this is where this type of architecture helps a lot. It decouples components. It allows them to work in their speed. It allows buffering, and once this traffic subsides, queues can be cleaned up, work can continue as usual without impacting your customer experience. Good. I want to show you a demo, and I'll explain quickly what the demo is about. It's fully serverless, as expected probably. And it's an event-driven system based on a scatter-gather pattern. So you'll see in a second why it's called this way. We'll do a bit of image processing in this demo. This is from left to right. So imagine on the left hand side, you have your S3 bucket where you can upload images to. This could be an image of a book cover, and this example is actually a book cover that I will bring. Now, based on this image, you want to do multiple processing steps. Those processing steps, they should not happen in order, so to say, and they also shouldn't happen synchronously, because we should have certain flexibility. So in the middle part of this architecture, you have all of those processors. In our case today, we have 2 Lambda processors that do something, but you could easily add, at any point in time, without the redeployment of this whole architecture, processors in the form of an EC2 machine, in the form of an external service, everything that can consume from a REST API, from SNS, can be used as a processor. Processors can enter the system at any time, and they can leave the system at any time. Nothing will break because one of the processors is having an issue. This whole architecture, this pattern is called scatter and then gather, because on the left-hand side, you enter with an image or an item, and then the work is, so to say, scattered across the field, across all of the consumers or the processors. We're taking this image from S3, and immediately it will publish a new object, a put object event. And this event will be entered into this SNS topic. So this is a topic which can have multiple subscribers. So every single one of those processors will have a subscription on this topic and will essentially wait until something comes through. And so if an image is entered into this topic, the subscribers will get notified, and they will go to this S3 bucket and take the item that was just added, and they do their processing. The processing that we'll do in this demo is on the upper hand here, we'll do image recognition with a service called Recognition, Amazon Recognition. And it will try to identify entities, scenes, different things in the image, so visual identification based on a machine learning model that AWS trained before. And we have a second processor, which is, again, based on a Lambda function, and it will call a service called transcribe. So transcribe, as the name says, will try to read from a PDF or from a JPEG or from a PNG. It will try to read if there is handwritten or printed text in this file. And it will try to, first of all, read it and transcribe it, but also place it. So if it's maybe a table, it will try to bring it into context, that this is a table, this is one line, and so on. The result of both of those service calls, they are just JSON, so you will get a JSON response. And that JSON response, we will push into another serverless service, namely SQS. So we have a processing queue. On this side, this is the gather stage, right? So we scattered all kinds of stuff, and now we're gathering it in SQS. And here we're using SQS because maybe we want to do things in a more orderly fashion. We take all of those items into a queue, and we let a single Lambda or some other form of compute process those events and save them to a store. And here, for simplicity, I'm using a DynamoDB table, but this could be any type of storage. Maybe this is, I don't know, maybe this is a file and you want to do, you can't open multiple file streams. So this is where this gather phase is really important, because you will have a single processor that will take out of this queue and can, one by one write into a file or a database, whatever it is. So you see, this is the idea of the scattering on the left-hand side and the gathering on the right-hand side. The way we will visualize this is by running a little front end, a very simple website on AWS App Runner, which is in a container. it's essentially just a Node.js app that will read from this DynamoDB table. So all it does, it's reading from the DynamoDB table and showing us the results in a table view. And so the image recognition that we're doing, I'm going to use this image on the left-hand side, which is a book cover, some random book cover, and I want the processing from recognition and text rec to show up in my DynamoDB table. What recognition, for example, will tell me more or less is that this is most probably a shark with a high confidence. And what text rec will tell me is that we have multiple lines, the animal files, we need sharks, and so on. And it will try to give me as much context and information about the text that it finds on this image. Good. So let me jump over to my console. Marco, maybe you can tell me if you can see.
Yeah. Yes, it's all good.
Good. So what we see here is the starting point. If I jump back to this little diagram, our starting point was an S3 bucket, and I want to upload an image here. And instead of having to write code that consumes out of S3, we use a functionality from S3, which is publishing an event on new object creation. So as soon as I drop an object into this S3 bucket, this will trigger an event, a message in my SNS topic. And I didn't write any code for that. This is just configuration. It's just a feature of S3. And I'll take my little shark book, and I'll drop it here. It's a JPEG, and I'll just upload this. And this is uploaded. So far, very standard. So now this whole pipeline kicks off. And what we're expecting is that this SNS topic picks up this event, and those two Lambda functions do their work. And we can actually, in the end, see the processing results in our DynamoDB table. Maybe let's look at the Lambda function as a next step. So this here is, excuse the name is auto-generated from a CDK script, or a CloudFormation stack, so to say. This is the Lambda that does the recognition, so the image recognition. If I look at this function overview here, I can see that the input is actually an SNS topic. So this makes sense, right? We want our Lambda to be hooked up to this SNS topic. And what happens in the background is, as soon as, essentially all the time, Lambda is polling from SNS. And as soon as an object lands in this SNS topic, Lambda will receive this notification. And our code is visible in the browser. You can also, of course, have your code in a version control repository. But here we can see the code. We can even test it in the browser. It's Node.js. And all it does is really, it imports the AWS SDK, a little component that that we're using to consume or to write into a queue. And your input is an event. This event will contain this message about, hey, there is a new object in your S3 bucket. And so we'll retrieve the name of the item and the name of the bucket. We'll do a few console logs, and we return, or we write essentially into, we call to recognition to get these labels, so the image processing. And as soon as the recognition client, here it's called REK on line 28, it will return something, an analysis result. And that, again, we do a console log, and then we also return it. And when we say return, what we actually mean is we write into this SQS queue that is there to process all the results. And so you can see that you can see that, for example, this processor up here, maybe it takes 10 seconds, and this processor down here takes 10 minutes. Whatever the case may be, we're totally decoupled from each other. So SQS is just there to process at whatever time those results come in. What we can also do quickly is have a look at the monitoring aspects of this. So we have our CloudWatch metrics, which we immediately get by just creating a Lambda function. So there is no, I don't have to install any agents or do log handling and maybe log rotation and all these kind of things that I would need to do with a server. I just get out of the box my CloudWatch metrics. I could see how many times this thing was called. I would see the duration. I would see the error counts and so on. And I can also straight away jump to the logs in CloudWatch. So these are the logs that you remember we had a few log messages in here. And these logs, I use them, and here I'm using them very excessively probably, but I want to use them so I can debug my system. I can understand what's going on. And this log is essentially from a few minutes ago. And we can see, for example, this is the key name. This is the file name, sharksbook2. And I'm logging a few things. But this is a typical Node.js type of log that we see in CloudWatch. So what we expect is that both of those lambdas, they just ran, they called recognition or textract, and they wrote their analysis results into SQS. Then there's a third lambda that picks up those results and writes them into a DynamoDB table. The only thing that is interesting in this second lambda is that we're using the message ID from the very beginning to correlate the results from both of those lambdas. There could be even more. So you need something, a correlation ID to understand that, okay, this result is about item X, and maybe the next result is about item Y. And that information you use at the end to write into a DynamoDB table. And if I go to DynamoDB itself and I do a refresh, I'm expecting to see another item, this one, sharksbook2.jpg, and I can make it a bit bigger. And I see 3 things. I see an image URL, very standard, and then I see the results from recognition, the result from textract. So these are attributes in this DynamoDB table. And I will take this and copy it to something more readable. And let's do a format here. So this is the result, essentially, that I received from recognition. So it's telling me, first of all, what it recognizes here is a shark with a confidence of 99%. And then it's giving me this bounding box. So the bounding box is visually, if you want to draw a rectangle on this image, saying, on this image, at these coordinates, I'm seeing a shark, I'm identifying a shark. And then it's giving me, so to say, in a sorted fashion, other components that it sees, other entities maybe, or scenery, like sea life, animal, and fish. And it goes even further. So here it would say great white shark, so the type of shark with a confidence of 86%. So this is what I'm getting from recognition, and it's in my DynamoDB table. And here's the result from textract. I can do the same. I'll make it a bit more readable. And textract also gives me a very similar JSON output. It tells me, okay, we see one page. That makes sense. It's a single picture that we gave it, but you could give it a PDF with many pages. And then it has this hierarchical structure where it describes the table, the page. So here we would see this is a page, a bounding box, and then we see each line. So the animal files, maybe I can show you this. The animal files was here. Again, we see bounding boxes, and here's the second line on line 94, this we need. And so it describes the whole table. And this is what happened in this whole architecture, all using serverless technologies. I don't have to scale any of this. I could send in 1,000 pictures on this end, I would still get the same performance. I would only pay for essentially what is used. So while this thing here is not doing anything, so while, let's say, I'm not using the Lambda functions to process anything, all I would pay for is a few cents probably for this DynamoDB table, maybe for this S3 bucket. But I have no servers which are just idle and sitting around, not for the topics and the queues, and also not for the Lambdas or the AI services in text extraction recognition. And that's really the beauty. And maybe the last component I wanted to show you is this App Runner front end here. What App Runner is, it's a service that allows me to bring a container, drag and drop it into this little console here, and say, host this container. I can define, I have maybe port 80 or port 443 open. In this case, it's really a front end. And what it will do is it will host this container. It will give me an endpoint, so this default domain here, and it will just run it. And it gives me logs and metrics as we've seen before. So we're getting very close to a Lambda without me configuring a Kubernetes cluster or any of this. So when I click on this, I get my very ugly, serverless text recognition website, and I can say, show me the results, and it shows me a bit of a table view of what we just saw in DynamoDB. So again, here we see our Sharks book, JPEG, with the results of recognition and text extract. Yeah. So that's really it from my side. Any questions from anybody? Any comments about this? Happy to answer.
It's excellent stuff. Thank you so much, Ramon. So I do have a question from my side. So we quite often see clients trying to port over a bit of monolithic applications to Lambda, and then they run into sort of timeout issues and not executing, limitations with CPU and RAM and so forth. And we usually advise these clients that it is not a good idea to just drop in your existing code into Lambdas if it is an existing application. So how do you advise as an AWS person clients trying to achieve a porting of an application to Lambda?
Yeah, I mean, porting to Lambda or porting to serverless in general, I think if we talk about the latter, there is a bit of a re-architecture to do, and obviously a huge re-architecture is not something that you just do on a random day, but you can do a bit of a transition into containers and then host those containers in a serverless fashion. So more often than not, I see that those monolithic applications, even if you break out smaller components, they can be moved into a containerized environment. And that also makes sense from a environment and development perspective, because it makes your local environment similar, or I would almost say the same as your productive environment. And then you take that container and you move it into, for example, App Runner, or if you want more control, into something like ECS or EKS. And you can still use Fargate, right? So you still get a serverless benefit without having to rip apart your whole application into very, very small components that fit into a Lambda function.
Okay, cool. Thank you for that. I don't see any questions from the audience so far. If you have any, just type them into the chat. So as I don't see any, I'm throwing in another one from my side. So when you do an App Runner configuration, does that actually launch in the background some Fargate containers, or is that fully abstracted away so you don't see it, what it actually does?
No, this is totally transparent to the customer, to the user. Really, the goal was to make it as easy as possible for somebody with a container to host something, without, if you've seen, let's say, Kubernetes before and EKS, there is quite a bit of heavy lifting before you even launch a single workload or a single worker node in that case. And that's taken away with App Runner, where all you need to know is, how do I package my existing code into essentially a Docker file and a container? Maybe I have to choose a base image and a few of those things, but everything else you can leave to AWS.
Okay, cool. So that means you won't see the ECS tasks that are spun up. So that's handled by App Runner. Yes. Okay.
Yeah.
Okay.
Yeah.
Good. Yes, and in the background, most likely it's something like Firecracker or so containers that are coming up.
I don't actually know. It's not something that we essentially make public or let the customer influence.
Yes, that's fine. No worries at all. Good, cool. So last chance to ask any questions. Type them into the chat. Good. So then let's go to the next slide, please. So Raman, thank you so much for giving that speak. It was excellent. I learned quite a bit. I hope the audience did as well. So well prepared, and the demo worked without any issues. So great job there, Raman. It's always a bit of a gamble if you do live demonstrations, but I assume you have done that so many times that you know exactly that it will work. So great job there.
I had a backup video as well, just to be
good.
sure.
Okay. And AWS just works, so it's not that big of a gamble with AWS. Yes, cool. Good. Next slide, please. Good. So thanks everyone in the audience for being part of this webinar. So great to have you here. So if you need anything with AWS or with Kubernetes or containers, reach out to us. We are always here. hello@codebit.ch is the way to reach us. The easiest way. Just reach out. We are here to help. Good. Next slide, please. Good, and as this is a webinar series, of course, we will have a next webinar. So webinar 3, which is happening on the 20th of September, is about Proton. Proton is quite a new service on AWS. This is self-service for developers. So if you're doing a lot of development work with containers or even Lambdas, so Proton can also be used for Lambdas. Proton can help you building these pipelines and monitoring system and execution and integrating into load balancers and Route 53 and everything that you need to get your application up and running on AWS quickly. Proton is the service to use because it abstracts away a lot of that complexity with the underlying service. So if you haven't registered yet, please register. 20th of September, always on the same link, and you also get an invitation if you have participated here after the webinar. Good, and I think we are going to the next slide. A big thank you again. Thanks a lot for your time. Looking forward to host you at the next webinar. Thank you so much. Talk soon. Have a great evening and goodbye.
Thank you, everybody.
Cheers.